today we are going to be talking about future value, the future value formula, and some of its applications. We're going to look at the sort of easier questions today, and then at the sort of more difficult sorts of questions that get asked on Thursday. All right, so first of all, future value formula looks like this. It's on your formula sheet. F equals X 1 plus I to the n minus 1 over I, where X equals the equal payments per period. So the other word that we use there is going to be our installment. So an installment, the word installment means a regular payment. Okay, a regular payment. Okay, so like a monthly payment on something. Okay, so I'm sure if you speak to your parents, they'll be able to tell you this as well. For example, when you buy a house, you have to make a payment every single month towards your house. If you buy a car and you've borrowed money to pay for your car, you've got to pay a regular payment every single month. When you are saving money, like saving towards a pension, you make a regular payment every single month towards your pension scheme. Okay, so future value and present value, for that matter, are only used where there are regular payments. If there are no regular payments or the money is just sitting in an account earning interest, it will be compound interest. Okay, so future value can only be used when regular payments or installments are taking place. All right. The letter I represents our interest rate. N represents the number of payments made. Okay, so it's different to compound interest and reducing balance depreciation. N is the number of payments that are going to be made. All right, now, how do we know when we are supposed to be using the future value formula? Future value is used when we have some kind of savings or investment or a retirement annuity or a pension. Okay, so we use future value when we are trying to calculate savings. So in other words, what's happening here is that together with regular payments, this amount of money is going to grow. Okay, that's what we want to see happening with future value. So that as time, so time would increase in this direction. Okay, so as time goes by, the future value of your investment grows. Okay, so that's why it's used for savings, investments, retirement annuities, pensions, that sort of thing. Often for students, they look at future value and present value and they don't know which one to use in which situation. So that's why I make mention of this now. All right, so you have got 4 different variables. You've got the F, the X, the I, and the N. Right? Theoretically, they can give you any one of the 3 and ask you to calculate the other one. So if they give you X, an I, and N, they can ask you to calculate future value. Or if they give you future value, an I, and N, they can ask you to calculate X, okay, the installment or regular payment. Right, they could ask you to calculate the interest rate. Those sorts of questions are a little bit more unusual. And they could ask you to calculate N, and you'd use logs. Okay, which is what we were talking about last week on Thursday, but we'll talk about that later on. All right, so let's have a look at some examples. All right, the first one says, suppose that 1,500 Rand is invested every month starting immediately. Now, sometimes we start immediately, sometimes we don't. Okay, so there can be an immediate payment with future value. We can't have that with present value, but they can be an immediate payment. Okay, so starting immediately for a period of 12 months. So in other words, if we go back to our timeline, All right. What we are saying is that at T0, there is a payment of 1,500, not 15,000. Okay, at T1, there would be another payment of 15,000. At T2, there would be another payment of 15,000. Da, 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 da. So T11, there's a payment of 1,500. And at T12, there is a payment of 1,500. Okay. The interest rate doesn't change from start to end. It is 18%, so that's 0.18 compounded monthly. We would have to divide that by 12. The future value of the investment after 12 months would be the sum of all the payments together with the interest earned. Okay, so subbing that into our future value formula, they are asking us to calculate F. Our X is our regular payment or our installment. So that would be 1,500.1 plus our interest rate, 0.18 over 12. And now, how do we calculate the number of payments? So can you see that if you start at T0 and you pay every single month, okay, it's going to be 12 times 1 plus 1. So there would be 13 payments of 1,500 Rand. Does that make sense to everybody? Over I, 0.18 over 12. Does that make sense, guys? Are we all okay with that? Any questions?
We can also have thumbs up, thumbs down. I see that most of them says yes, it making sense on the chart.
Yeah.
Nice.
So, Kutwano, it depends. If there is an immediate payment, then yes. If there's not an immediate payment, then no. So you've got to be very careful about how you read your question. Okay. Very, very careful. Also, make sure that when you open a bracket, you close a bracket, because your calculator won't like it if you open 2 brackets and only close 1. Okay, so just be careful of that, because it will give you a maths error and you'll think that you've done something completely wrong when in actual fact, it's just that you haven't closed a bracket. Okay, I'm just putting this into my calculator. And you guys can share your answer. I think that's what you must be doing in the chat by now. Okay, Mbalenhle, yes, that's right. I am moving quite fast. All right, I'll happily explain it again. Masindi, that's not the answer I got, Masindi, unless I... Okay, so in other words, what I've done here is I've said that there are one payment a month for 12 months, plus your immediate payment. That's why there are 13 payments. Okay. That's it, iPhone. That's it, Sisipo. Naledi. Good. Okay, all of you are getting the correct answer. Okay, so here, this would be 21,355 rands and 24 cents. Okay, so that's it. Okay, so let me just go back here. Nondumisa, I hope I've answered your question. Mbali, I hope I've answered your question. Hlobi, I hope I've answered your question as well. Okay, so it's one payment a month for 12 months, plus that initial payment as well. Okay, that immediate payment in the beginning. Okay, because you're starting to count at T0, you're not starting to count at T1. Okay. All right. So that's how you would use the future value formula to calculate the future value of an investment. Okay. No, Manently, you don't get penalized if you don't write the rands. Okay, they won't do that to you. Okay, so you're never penalized on units. Also, if you round incorrectly, they probably won't penalize you for that either. It just depends on, I mean, if let's say here, I mean, you couldn't round it to anything other than 2.4, but let's say you had comma 2.3. They also won't penalize you for that. There's only one place in paper one where they penalize on rounding, and that's when you use the quadratic formula in question number 1. Other than that, they don't penalize. All financial maths is marked as, mind you, that's your entire paper actually, is continuous accuracy. Okay, so whoever's sitting and marking this will be sitting with a calculator and just making sure that if you have made a mistake, that you are being continuously accurate. Yeah, sure, Nkaniso. So no. So DeAndre, if there is no immediate payment, then no, you would not add 1 to your end value. So sometimes you do if it says starting immediately. If it doesn't say starting immediately, then you wouldn't. Okay, and we're going to look at both situations. All right, there's the formula again quickly. All right, and I'm going to go back down. Okay, so let's consider Thomas, who starts saving money in a unit trust fund. He immediately deposits 800 Rand into the fund. Thereafter, at the end of each month, he deposits 800 Rand into the fund and continues to do this for 10 years. Interest is 8% per annum compounded monthly. Calculate the future value of his investment at the end of the 10-year period. All right, so again, this question tells us that there was this immediate deposit, okay, that took place in the beginning. This is not always the case. It just happens to be the case with the first 2 examples that I have given you. Okay. He's doing this for 10 years. Interest is 8% per annum, compounded monthly. All right. So calculating the future value of his investment, the future value is X, 1 plus I to the N minus 1 over I. Yes. Okay. So look at when the payments start. Okay. If they say something like this, where they immediately deposit money into the fund, often this implies that you have to plus 1, right? But not always. But we'll talk about that in our lesson on Thursday. But in this case, it does. All right. Other key words that you need to look for is what they're asking you to do. So calculating the future value is important. Have a look to see whether there is a regular installment, and if so, what it is, because that's the value of X. All right. The other thing that we need to be able to do is we need to be able to calculate the number of payments. So see how long these deposits are taking place for. So can everybody see that he's doing this for 10 years? So there are 12 months in a year. There are 10 years. So that makes us think that there would be 120 payments. Shame, Tegofatso. You got the answer already. Well done. But because of this, again, this immediate deposit, we would have to add 1. So there would be 121 payments. Quite right. Okay, so sub in and let's see what you guys get as an answer. You can, like Tsegofatso, send me your solution and we'll see what you get. So I'm just going to go and look at your answer again. Okay, Kutluano, you say you're a bit lost. Lihlo, that's perfect. Nolutando, that's perfect. Menentle, perfect. Okay, so Masindi, good. Sisipo, yes. Kutluano, what are you confused about? If you can explain to me what's confusing you, then I can help you. So that's what you should have had, and then got a final answer of 148,132,54, which a lot of you did send through to me, yes. Sihawu, I'm not sure how you got 146,356,82. Just check your answer against mine, Sihawu. Yes, Kutwano, that's quite right. Okay, so there are 12 payments in a year because there's 12 months in a year. Okay, and he is depositing 800 Rand at the end of every single month. Okay, so he will make 12 payments in a year for 10 years. So that's why I'm saying 12 times 10. And then the reason that I'm adding 1 is because, again, in this example, it is an immediate deposit of 800 Rand. Okay, so Mbali, be careful. When you say 8%, you mean 8 divided by 100. 8 divided by 100 is 0,08. 8 divided by 10 is 0,8. Okay, so just be careful. Chloe, I wonder if it isn't maybe the way in which you're using your calculator. Are you pressing the fraction button? So start off and press your fraction button. And then navigate up here to the top. And then put in your 800 bracket. Okay, and then you'd press 1 plus, and then press the fraction button again to put the 0,08 at the top of the 12 of the bottom. Close your bracket, press the exponent button to put in the 1 to 1, minus 1, and then you got to close your bracket again. All right, and then you got to go down into the bottom, and you're going to press 0,08, press the fraction button again, and then you could put the 12 at the bottom. Try that, Chloe. There we go. Yeah. Okay, so be very careful. Your calculator is very fussy about brackets. Okay, if you open a bracket, you got to close it. Okay, so you can see here, I opened a square bracket, I opened a round bracket, I closed a round bracket, I closed a square bracket. If you don't do that, your calculator will have a heart attack. Okay. All right, cool. All right, I hope that's all right for everybody. Let's have a look at another example. So here we've got Jessie, who deposits 400 Rand into an account, paying 14% per annum, compounded half yearly. 6 months later, she deposits 400 Rand into the account. 6 months after this, she deposits a further 400 Rand into the account. She then continues to make half-yearly deposits of 400 Rand into the account for a period of 9 years from her first deposit of 400 Rand. Calculate the value of her savings at the end of the savings period. So again, here, they didn't use the words future value. So how do you know that you're supposed to be using the future value formula? Well, first of all, they're implying that it's some kind of savings. Second of all, there is this regular 400 Rand that is being paid in, okay, at a regular point in time. So every 6 months, Jessie is putting 400 Rand into this account. Those are your clues that you've got to use. Yes, quite right, Voloshan. Okay, you want it, she wants to save money. She wants to have a future value, retirement annuity, or some kind of savings, etc., etc. Okay, so we know what they want us to do. We can see here in this situation, again, they're asking us to calculate future value. Right? So what's the value of X in this case? Sekatela's already got the answer. Okay, Sekatela, I got a different answer for you. Yes, the 400 is the X. Good job. Well done, everybody. Okay, 1 plus the interest rate is 14%. So we'd write 0.14, compounded half yearly. So what are we dividing the 0.14 by? So that's the correct value. Pinga, Molebo, sorry, Menentle. Menentle, you've got something wrong there. Yes, we're dividing it by 2. Good job, everybody. Dividing it by 2. Okay, now N, your exponent. From reading this information, what do you think your exponent should be? What do you think the exponent N should be? Okay, so iPhone, with the reason that we're dividing it by 2 is because the interest rate is compounded half yearly. Okay, so remember our first lesson on compound interest when we changed the compounding period. Okay, so we would have to divide by 2. All right. Okay, now I think that this example, which I took out of my textbook, is a little bit unclear, which is unfortunate because, you know, especially with situations like this, we need to be explicit, right? The English in this question is implying once again, all right, that there is a payment that's taking place in the beginning. She deposits 400 Rand into the account. Okay, 6 months later, she deposits another 400 into the account. 6 months after this, she deposits another 400 Rand into the account. She then continues to make half-yearly deposits of 400 Rand into the account for a period of 9 years from her first deposit of 400. So you can see there, they haven't said it's an immediate payment, but she continues to make half-yearly deposits of 400 Rand into the account for a period of 9 years from her first deposit of 400 Rand. Okay, so they're not saying it very well, but they are trying to imply that N is going to be 9 times 2 plus 1. Okay, I think for this question that if you used N equal to 18, they couldn't penalize you. Okay, but we're going to use 19. All right, minus 1. Where do we multiply by 2? Oh, you mean why are we multiplying the 9 by 2? Okay, because she is making half yearly deposits. So that's 2 deposits a year for 9 years. Okay, 2 deposits a year for 9 years. Remember, N represents the number of payments. Okay, so we would end up here with, or Jessie would end up with 14,951 Rand and 59 cents. Okay, yes, Masejo. Yes, everybody. Klobani, I think. That is a very good question. This is where the English makes things so difficult for us. All right. When it says here, she continues to make half-yearly deposits of 400 Rand into the account for a period of 9 years from her first deposit of 400 Rand. They are implying that she makes that initial deposit, and then for 9 years after that, she makes 2 deposits a year. Okay, but that's why I said to you, I think you would be forgiven in this case for using 19 or 18. I think it is a little bit ambiguous. All right.
Hello, ma'am.
Hello, Tsegofatso. How are you?
I'm good, and how are you, ma'am?
I'm fine, thank you.
So the word isn't like, by my understanding, doesn't it mean like there's a difference between deposit and a payment? So since they're saying he deposited 400, but if it's half yearly, means he's paying 6 months later every time a payment. So doesn't it mean that there's no added, like that one that we added there? Does it mean it's not there? Because that's when he made his first payment after 6 months. I don't
You
know if you
see,
get.
yeah, I understand what you're saying. You know, this is the horrible thing about financial maths is, you know, you've got to be so careful about the words and the way something is phrased. Okay, so whether they use the word deposit or whether they use the word installment, that doesn't really matter. What's
Yes.
important here is that they are implying that 400 Rand is being paid on a regular basis, as you said, every 6 months.
Yes.
The bit that I've highlighted in blue says she then continues to make half-yearly deposits of 400 Rand into the account for a period of 9 years from her first deposit of 400 Rand. So
Yes.
those words from her first deposit of 400 Rand imply that she made a deposit in the very beginning. So in other words, in the first year, she made 13 payments and not 12. And then for every year after that, she made, I beg your pardon, not 13 payments because she's making half yearly payments. So she would have made 7 payments. She would have made 3 payments in the first year. 3
Yeah.
payments in the first year, and then 2 payments a year for 9 years after that. That's what they mean.
Oh, okay.
Okay.
I get it.
All right. No problem.
Thank you.
No problem. You know what, Masejo? If the question was unclear, which it won't be in tests and exams, then we can't penalize you. Okay, these questions that I'm using here come out of a textbook. We are going to look at some exam questions as well, but we can't look at the exam question first. We've got to look at the textbook questions. All right, so that's why I'm saying here, I think they would accept 19. I think they would probably also accept 18 in this case. Okay. Yes, Vuyo, that's exactly it. Okay, Mbalenhle. Okay, so in other words, if you are making half yearly payments, you are paying every 6 months, twice a year. The question is implying that in the first year, there are 3 payments in that year, and then 2 payments a year for 9 years after that. Okay, Mbali? Lobani, it depends. It really just depends on the question. All right. Sometimes, yes, you'll add it in. Let's see. Let's tell you what. Let's find an example where you don't have to add that one, Shane, because I think that is confusing Let me just see if I can find one. Okay, Swanaka, I see you have got your hand up as well. Swanaka, did you want to ask something?
Yes, ma'am.
Go for it.
Ma'am, I want to ask, will you get marks if we indicate a number line?
No, absolutely. Use your number line. There's no problem with you using the number line at all. Okay, it does help a lot. In fact, let's use this one as an example. Okay, let's go to this question over here. Okay. So I'm jumping forward a little bit, but I mean, we've practiced how to calculate future value quite a lot of times. All right. So let's look at this. Dana has just turned 20 and has a dream of saving 8 million Rand by the time she reaches the age of 50. She starts to pay equal monthly amounts into a retirement annuity, which pays 18% per annum compounded monthly. Her first payment starts on her 20th birthday, and her last payment is made on her 50th birthday. How much will she pay each month? Okay, so there's a lot going on in this particular question. A timeline is a very useful way of us being able to visualize the problem before we go and substitute into future value, right? So what they're implying here is at T0, this is when it is her 20th birthday. At T1, T2, T3, all the way up. Now we get down to where she's going to be turning 50. Okay, so how many years need to go by? Yes, how we're solving for X. Quite right. How many years would need to go by if you have just turned 20 and then to the age of 50? How many years would need to go by? Exactly, 30 years. 30 years, right? So if we take 30, and remember she's paying equal monthly payments, we've got to times that by 12. All right, what would we get? Yes, it does. It does look like an MP. I thought maybe it wasn't for lotion, but it is going to be another immediate payment. It's a bit irritating, isn't it? Okay, 360 is correct. Quite right. So coming down here, we would end up at, I don't know, what's it? 359 and then T360, okay? She is making a payment on her 20th birthday and here on her 50th birthday. So it looks as though there is this immediate payment taking place in this question as well. She makes her last payment on her 50th birthday. So she will make a payment then. And she wants at this point in time to have 8 million Rand. Okay. Yes, Kotwano, we're going to add 1. Okay. So N is going to be this. So there would be 361 payments in this case as well. Tsagfatso's already worked out the answer. Good, Tsagfatso. Okay. Shisana, yes, that's good. Well done. I'm just checking my answer. I got the same as you. Okay, good, Shisana. Well done. Okay, so now subbing into future value. Okay, we know it's future value because it's savings. So our future value is going to be 8 million equals X. Okay, how much will she pay each month? Implies we need to calculate the value of X. 1 plus our interest rate, 18% per annum, compounded monthly. We've discussed that she would make 361 payments. And here 0.18 over 12. Okay, good Pinga, yes, absolutely. Okay, so now matrix, in order to solve for x, you are going to cross multiply. All right, so you're going to cross multiply this 8,000 with the interest rate, and then you're going to divide by the hard bracket. Okay, so in other words, x is 8 million times 0.18 over 12 divided by our square brackets. Okay, like so. All right, so I'm getting an answer, or I got an answer, should I say, of 558 Rand and 41 cents. That's well done, Zerufatso and Sisipo. Good. Yes, Miss Cindy. Menentle, something went wrong there. Have you found your mistake? Yes, Pinga. Good, Shisana. Good, Zerufatso. Okay. Are we all right with this, everybody? Are we all right? You sure? Okay, so Zerufatso, it tells us that she starts to pay equal monthly amounts into a retirement annuity. Her first payment starts on her 20th birthday. And her last payment is made on her 50th birthday. All right, so because they are saying her payments start on her 20th birthday, that's why there is going to be this payment at T0. Okay. Sihawu, yes, you can do that if you want to. Okay, that's not a problem. Okay, Shem, I think you did ask me that earlier and I didn't answer you. Okay, but yes, Sihawu, that's fine. Okay, so Vuyo, your timeline. But how do we know when we are given F from the statement? Oh, okay. All right. You see, again, you've got to read it very carefully. So Dana's just turned 20 and has a dream of saving 8 million Rand. Okay, so that means if she has a dream of saving 8 million Rand, that implies that she wants that 8 million Rand as her future value. Okay, that's what she wants to save up by the time she gets to 50. So she wants a future value of 8 million Rand when she turns 50. So that's how we know that they mean that F is 8 million. Okay. She starts to pay equal monthly amounts into her retirement annuity, paying, that's the interest rate. Her first payment starts on her 20th birthday. So we always start our timeline at T0. Always, always, always. In this case, because they've said to us her first payment starts on her 20th birthday, they are implying that there is an immediate payment. Okay, or her first payment is on her 20th birthday at T0. If her last payment is made on her 50th birthday, that's why we have this last payment of X here at T360. Okay, and she continues to pay every single month throughout those 30 years. Okay, so in her first year, there are 13 payments, and then every year after that, there are going to be 12 payments a year. That's what they mean. Okay, I hope that that makes things a little bit clearer. No, it's not. And Noluthando, you could also make payments at the beginning of the month or at the end of the month. Okay, so that also makes a difference in financial maths as well. But here we're just talking about payments at the end of the month. We will talk about what happens when payments are made in advance as well. Okay, but we'll talk about that next time. Show the operations. So Kotwano, what when you say operations, what do you mean exactly? You cross multiplying. So you're multiplying your 8 million with your I, and then you are dividing by your hard bracket. Okay, so there's your times, and there's your divide. Okay, in order to get X on its own. This step actually does not need to be shown, but I'm doing it now with you guys just so that you can see where it comes from. Okay, so marks here, okay, you've got to sub into the correct formula. I'm sure there would be an accuracy on the 361. Okay, and then a mark on the answer. Right, Katleho, what do you want to ask?
Ma'am, I have 2 questions, I think.
Sure.
Okay, ma'am. From my school, ma'am, they have a formula for X. It's literally the same formula. It's just that they put X as the subject of the formula to make it easier. So, ma'am, you said what's that, ma'am? I forgot the word.
Substitute?
Putting in the, yes, ma'am, that word. Ma'am, substituting in the correct formula, like you have a mark for it. So, ma'am, am I going to be penalized for actually making X the subject of the formula and not using the F formula? So will I still get the mark for the formula, ma'am?
You will.
Okay.
You will still get the mark for the formula. So
Okay,
if the thing that you have subbed into is, I mean, I'm writing it here for you underneath. If this is what you are subbing into like that, then they're not gonna penalize you. Okay, is that what they've shown you to sub into? Does it look like this?
Yes, ma'am, it does look like that.
That's fine. Okay, no problem at all. It will be the correct formula. Okay. And then what's your second question?
Ma'am, my second question is, ma'am, is for like our examination, ma'am, our examination. Is it going to be like last year, ma'am, where you have like just a person randomly changing their mind in the middle of the year and the interest rates changing in the middle of the year? Because then that's so complicated.
Katleho, they don't generally ask those sorts of questions in grade 12 anymore. Those complicated timeline questions where there are deposits, withdrawals, changes in interest rate, etc., are generally for grade 11. Your questions will focus, you'll see that the 15 marks on financial maths, they normally ask a question on reducing balance depreciation. They ask a question on compound interest. They may ask a question on future value. They always ask a question on outstanding balance on present value on loans. So that always gets asked. And that's about it. It's not there's so much work that we do actually for such a tiny little section. I mean, I must say it's tiny. I mean, it's 15 marks out of 150 in paper 1. That's not a big section. You know, I mean, if you compare it to functions or calculus, you know, I mean, even probability counts for more than financial maths. Okay.
Thank you, ma'am.
All right, no problem. No, I didn't. I didn't reciprocate the fraction. I wasn't dividing by a fraction. Okay, all right. Now, let's do this question, but what I'm going to do is I'm just going to doctor this question quickly, all right? So what we're going to do is we're going to ignore that because I'm tired of that coming up. So let's just pretend that that's not there. Okay. Atalia wants to save up 400,000 Rand in 5 years' time in order to purchase a new car. She starts making monthly payments into an account paying 12% per annum compounded monthly. How much will she pay each month? So again, they are implying she wants to save money. Okay, she's making regular payments. We need to use future value. They're implying that the 400,000 would be our future value. When the question says how much will she pay each month, they are implying we need to calculate the value of X, the monthly payment. 1 plus our interest rate is 12% per annum compounded monthly. Now, what I probably should have done was done a timeline for you guys first. So T0, T1, T2, T59, T60. Okay, so she wants 400,000 Rand at T60. She starts making monthly payments into an account paying 12% per annum compounded monthly. There's no implication now that she makes an immediate payment. So nothing happens at T0. She starts paying here at T1. Okay. And she's going to do that every single month. Interest rate from start to end doesn't change. It's 12% compounded monthly. Okay, so here there is no +1. Okay, so it will simply be 60 payments. Okay, 5 times 12. Okay, -1 over. Okay, like that. Okay, so a lot of you are saying the answer. Let's just work that out quickly. Oh gosh. Sorry guys, hang on a second. I've stopped my calculator. I'm back. Okay, let's see what you guys are saying here. Yes, lovely. Well done, everybody. Okay, that's great. Okay. 4897, 78. Well done. Okay, so Swanaka, it is your monthly payment. Okay, X represents your installment, your monthly payment. Okay, so when they say how much will she pay each month, they are implying that you need to calculate the value of X. All right, so either they give you F, or they give you X, they give you I, they give you the number of payments, you calculate F. You can only calculate one unknown. All right, so in this case, they're implying the 400,000 was her future value. Our I is given, our number of payments are given. We need to calculate the number of payments. Okay, let's have a look what else. Yes, Sissy Paul, let's do that. Tell you what. let's take this out. Sorry, because I didn't do one like this, Sisipo, for this lesson, but let's do this. Okay, so Michael deposits 10,000 Rand into a savings account at the end of the year. No, that's not a nice one to do. Let's see if this one's better. Just trying to see how we can doctor this so that we can work out the value of N. Yeah, we would have to use logs. All right, but now what we would have to do here is we would have to remove, calculate the future. We would need to know the future value of, okay, so tell you what, why don't we go back to something that we already know the answer to and try and do it over here. Okay, so let's go back to this particular question, all right? So let's pretend that we didn't know that there were 361 payments in this particular case, all right? We know what the value of X is. It's 558, right? So if you wanted to calculate N, you've got your 8 million, which is your future value. Your X value is 558,41. Okay. Our interest rate was 18% per annum, compounded monthly. So this was 0,18. There's N minus 1 over 0,18 over 12. Okay, so this is what you were asking for. So what you'd have to do now is you need to isolate that bracket. So you're going to have to cross multiply the 8 million with the 0,18 over 12 and then divide by the 558,41. Okay, so when we get that, we would end up with 8 million times 0.18 over 12, divide that by 558.41. We end up with, now you cannot round off, you've got to keep all these decimal places. We end up with 214,895,865 equals 1 plus 0,18 over 12 to the n minus 1. So now we need to transpose that minus 1 and we'd need to take it over to the other side. So this would give us 215,895,865. Okay, the value of our bracket, we've got 1 plus 0.18 over 12. So that gives us 203 over 200 to the n. Okay, so now n equals log base. Put in our number. Okay, so that's what we would do if we wanted to calculate the value of n. All right, and then we would obviously have to use that log button on our calculator. There you go. Okay, do you see you're getting n is equal to 361? Okay, so if you did need to work backwards to n, okay, and use logs, this is how you would do it. Okay, I don't know who asked me to show you how to do that, but oh, it was Sisipo. Okay, there you go, Sisipo. Okay, that's how you would do it. All right, iPhone 2. So what we've done is we've used future value and logs to calculate the value of n. We knew that n was equal to 361 for this particular question because we've already worked it out. So we're subbing into future value formula. Our future value is f. This is our f. This is our x. There's our I. There's our I, right? You're going to cross multiply 8,000 times the I at the bottom. Then you've got to divide by the 558,41. Okay, so to get this number over here, this is 8 million multiplied by 0,18 over 12 divided by 558,41. That's what this number is. Okay, because I'm trying to isolate the base so that I can use logs. Then I have transposed the -1. I've taken it over to the other side, which is why it's now become this 215. Okay, that is my number. My base is what was inside my bracket. Okay, iPhone 2. Does that make more sense? Okay, because DeAndre, remember, n does not represent the number of times the interest is compounded. It represents the number of payments. Okay, so it's not compound interest. Okay, so you're not multiplying n by 12. Very common question, actually, that. Okay. All right, remember, in this case, there is one payment every month. Okay, in a year. So there would be 12 payments in a year. Okay, DeAndre. All right.